Find the limit as x approaches 0 of sine of 4x over x. If we try direct substitution, we end up with 0 in the denominator, so we need to try something else. Recall that property 1 of theorem 1.9 says that the limit as x approaches 0 of sine of x over x equals 1. However, it doesn't have to just be x. As long as the expression inside sine and the bottom are the same, you can use this theorem. So if we have something like sine of 2x over 2x, that limit would be 1 as x approaches 0. So if we look at our function, we have sine of 4x. If we have 4x at the bottom, then we could use this theorem. However, we can't just add a 4 at the bottom. Let's look at sine of 4x over x. So if we get a 4 at the bottom, then we would have sine of 4x over 4x, and then we could use this theorem. However, we can't just add a 4 at the bottom because we feel like it. Remember that we're only allowed to multiply an expression by 1. However, if we multiply the top by 4 also, technically this is just a multiplication by 1. So we can say that sine of 4x over x equals 4 times sine of 4x over 4x. So now we can find the limit of the second expression. So by theorem 1.7, we say that the limit as x approaches 0 of sine of 4x over x equals the limit as x approaches 0 of 4 times sine of 4x over 4x. In order to use theorem 1.9, we need to have the limit as x approaches 0 of sine of 4x over 4x. And we can use that by using our limit properties and taking the constant 4 and putting it in front of the limit. So we have 4 times the limit as x approaches 0 of sine of 4x over 4x. And remember that we can use property 1 of theorem 1.9 as long as these two expressions are the same. So the limit as x approaches 0 of sine of 4x over 4x is 1, and we get 4 times 1, which equals 4. So the limit as x approaches 0 of sine of 4x over x is 4.